The missing link between continents. Look at a map of the world. Notice the tantalizing proximity of Europe and Africa, separated by a sliver of water. A curious mind might wonder, why is there no bridge connecting these two ancient continents? It seems a simple enough question, yet the answer is a complex tapestry of geography, politics, economics, and engineering. For centuries, the idea of a physical link between Europe and Africa has captivated imaginations, sparking ambitious dreams and daunting challenges. The Strait of Gibraltar, a mere 14 kilometers at its narrowest point, stands as a formidable barrier to this seemingly straightforward connection. This narrow passage where the Mediterranean Sea meets the Atlantic Ocean is no ordinary stretch of water. It's a maritime bottleneck of global significance, a gateway for trade, and a strategic choke point for naval powers. The absence of a bridge between Europe and Africa is not for lack of ambition or ingenuity. It's a testament to the formidable forces, both natural and man-made, that shape our world. The challenges are immense, but so too is the human spirit of innovation. As we delve deeper into this intriguing question, we'll uncover the historical aspirations, technological hurdles, and geopolitical complexities that have kept these two continents tantalizingly close, yet frustratingly apart. The dream of uniting Europe and Africa is not new. For over 5 decades, engineers, politicians, and dreamers have pondered how to bridge this seemingly surmountable gap. The concept was first seriously considered in the 1970s, fueled by post-war optimism and advancements in engineering. Early proposals focused on a suspension bridge, a seemingly logical choice given the relatively short distance. However, the unique challenges of the Strait of Gibraltar quickly became apparent. The depth of the water, exceeding 900 meters in some areas, posed a significant obstacle. Building support towers in such depths would be a Herculean task, pushing the limits of existing technology. The idea of a tunnel, while technically more challenging, offered a potential solution to the depth problem. In the 1980s, Spain and Morocco, the two nations closest to the strait, initiated feasibility studies for a rail tunnel beneath the seabed. This ambitious project, if realized, would create the world's longest underwater tunnel, surpassing even the Channel Tunnel connecting England and France. Despite these grand visions, the dream of a fixed link between Europe and Africa remained elusive. Political complexities, economic realities, and technological limitations combined to keep this ambitious project firmly in the realm of dreams. Beyond the formidable geographical challenges, the Strait of Gibraltar is also a hotbed of political sensitivity and territorial disputes. Any proposed bridge or tunnel would need to navigate a complex web of international relations and historical baggage. The strait is flanked by Spain in the north and Morocco in the south, two nations with a long and often tumultuous history. Issues of sovereignty, border control, and maritime rights are highly sensitive in this region. The status of Gibraltar itself, a British overseas territory claimed by Spain, adds another layer of complexity. The construction of a fixed link would necessitate unprecedented levels of cooperation and trust between these nations. Agreements would need to be reached on issues such as customs controls, immigration, and security. The potential for delays, disagreements, and political posturing is significant, adding another layer of uncertainty to an already challenging project. Furthermore, the involvement of other international actors, including the European Union and various maritime organizations, would be unavoidable. Navigating these complex geopolitical waters would require deft diplomacy and a delicate balancing act, adding further complexity to an already ambitious undertaking. Section 4. The Gateway to the World, Navigating the Strait of Gibraltar. The Strait of Gibraltar is more than just a narrow passage between two continents. It's a maritime superhighway of global significance, a vital artery for international trade and naval traffic. Thousands of vessels traverse this narrow channel each year, carrying a significant portion of the world's cargo. Any bridge or tunnel would need to accommodate this ceaseless flow of maritime traffic. Large ships, including oil tankers and container ships, require significant clearance to navigate safely. A suspension bridge, even with a high clearance, could pose a hazard to shipping, particularly during inclement weather. A tunnel, while less disruptive to surface traffic, would still require careful planning and coordination. The tunnel's depth, design, and location would need to be meticulously considered to avoid interfering with existing shipping lanes and submarine cables that crisscross the seabed. The sheer volume and importance of maritime traffic through the Strait of Gibraltar add another layer of complexity to the challenge of building a fixed link. Balancing the demands of infrastructure with the needs of international shipping is a delicate balancing act with significant economic and logistical implications. Section 5. When nature intervenes, seismic shifts and engineering nightmares. Beyond the political and logistical hurdles, the Strait of Gibraltar presents a formidable natural challenge. It lies in one of the most seismically active regions on Earth. The African and Eurasian tectonic plates collide here, creating a zone prone to earthquakes and volcanic activity. Designing a structure capable of withstanding the immense forces unleashed by earthquakes in this region is a monumental engineering challenge. The bridge or tunnel would need to be incredibly robust, able to withstand not only the shaking ground, but also the potential for tsunamis triggered by underwater seismic events. Engineers would need to develop innovative designs and employ cutting-edge materials to ensure the structure's resilience. This would likely involve sophisticated damping systems to absorb seismic energy, flexible materials to accommodate ground movement, and rigorous testing to ensure the structure's integrity. The seismic risks associated with the Strait of Gibraltar are not merely theoretical. The region has a long history of devastating earthquakes, some exceeding 8.0 on the Richter scale. Building a bridge or tunnel in such a seismically volatile environment would be a high-stakes gamble, requiring careful planning, rigorous safety measures, and a healthy respect for the unpredictable power of nature.